Structured Query Language. The author Бекманова Гульмира. Let's see data types in SQL. Character strings. The first one is char. String with fixed length n. Any value from null to 255. Varchar n. String with variable length. Maximum length n from null to 65,535. Depends on vendor. Numbers. Exact and approximate. Exact. There are different types of integer. Big integer, small integer, and teeny integer. Money. Monetary or currency values. For example, $20.80. There are symbol plus number. Approximate. Real and float. Differ in precisions. Dates and times. Date, date time, and time. There are three types for date and time. Other types. All are simple and atomic. SQL Domains. A schema may contain zero or more domains. An SQL domains is named user-defined set of valid data values. The objects they may belong to a domain are known as domain constraints. A domain is defined by a descriptor that contains 6 pieces of information: name, data type, character set. Where the reference values must be checked: default value, descriptors for domain constraints. SQL statements or commands. The first one is the most important: create table. The second one, insert into. The third, delete from. The fourth, update. And one of the important two is construction select. Yes. Creating relations in SQL. Create table statement. Create table person with the next fields: identifier, char, with length 11, not null, name, varchar, with length 50, age, integer, credit score, integer, primary key, identifier. It is possible to have many candidate keys specified using unique, one of which is chosen as a primary key. Creating SQL domains. Create domain statement. The create domain statement names a new domain and defines the domain set of valid data values. A domain can be defined as follows: create domain upNum, char with length 3. There is apartment number. Create domain key code, char with length 4, its door key code. Constraint, constraint 1, check. Value is not null, not deferrable. Constraint, constraint 2, check. Value between 1000 and 9999. Deferrable, initially immediate. Creating relations and SQL. Create table statement. Create table apartment with next fields: number. There is upNum, not null. If you remember, upNum is name of the domain, the previous slide. Rooms, integer, key code. There is domain 2, key code, monthly rate, money, primary key, number. Next example shows us how we can add a column to a table. Alter table, apartment, add flu integer. Creating relations and SQL. Create table statement. Create table apartment with next fields. Number. There is upNum, not new. If you remember, upNum is name of the domain, the previous slide. Rooms, integer. Key code. There is domain 2. Key code. Monthly rate, money, primary key, number. Next example shows us how we can add a column to a table. Alter table, apartment, add flu integer. Creating relations in SQL. Create table statement. You can see the ER diagram in this slide. There are 3 entities. Example. Create table, tenant, with next fields. Tenant ID, char 11 not null, upNum not null, login ID, varchar 20, password, varchar 20, since, date, until, date, constraint, fk tenant ID, foreign key, tenant ID, references, person, identifier, constraint, fk upNum, foreign key upNum, references, apartment number. You can see that we create table tenant with 2 references to the table person and to the table apartment. Adding and deleting tuples. Insert a single tuple using insert into person. Identify, name, age, credit score. There are fields names. We insert the term values. You can see in example. Delete from person P. P is alias definition. Next row show us that we don't write the name of table person. We only write alias p.name is equal, comma, Simpson. SQL queries. There is select statement. I think all of us listening about select construction. There is the most important construction for database designers. Format, select, and after that we need to write field's name, from, after that we write the names of tables, and where we write condition. Examples. To illustrate 3 SQL queries. Query 1. Simple select one table. Query 2. Select with conditions, one table. Query 3. Select requiring a join operation. Observe how they are implemented. Measure the number of row operations. We have 2 tables, sales with fields seed integer as name string, rating integer, age real, and reserves seed integer, bid integer, and date. You can see 2 tables with the data. They have different structure. One of them with information about sales, second one about zeros. Query 1. Find the names and ages of all sailors. S. Instead of sailors. You can see the table of sailors. And now you can see the code of SQL query. Select s.sname, s.age from sailors. S is the alias of sailors. The corresponding SQL query. Now, animate the execution of the SQL query. Our result will have two fields, sname and age. Query result is also a database table. And now we start. Dusting. We select from the sailors two columns, sname and age, with values. Output only the required fields in the entry. Lava, Rusty, Zorba, and next one, Horatio. End of the algorithm. Summary of query 1. Result of SQL query is another table derived from original table. A simple analysis shows mistakes, projection operations, where n is size the number of records in table S. This query is also called a projection. It's the same as the project primitive is simply selected a subset of the columns. Query 2. Find all sailors with a rating above 7. We have instance of sailors with the next columns. See sname, rating, age. You can see the text of select statement. Select s.c, s.sname from sailors, S, where S rating more than 7. The corresponding SQL query. There is a select statement with condition. Now we need to select from the sailors all rows satisfy this condition. Now animate the execution of the SQL query. Our result will have two columns, seed and sname. Query result is also the database table. Now we will start. Dustin. His rating is 7. At this moment, CPU check the condition. No. Condition is false. Do not output this entry. Lava. His rating is 8. Is 8 more than 7? Yes. Condition is true. Output this entry. We include lava to our result table. Is the 10 more than 7? Yes. Condition is true. Output this entry. Rusty. Zorba. Durban? I think the same. Yes. And now we add these rows in the result table. Horatio. 9. He's rating. And now, is the 9 more than 7? Yes. And now, Horatio adds in the result table. End of the algorithm. Summary. Result of SQL query is another table. Row inclusion is determined by where clause. A simple analysis shows this takes selection operations, where n is size the number of records in table S. This query can be decomposed into eSelect followed by an eProject primitives. We have two tables, sales and resource. Query 3. Find the names of sellers who have researched bullet number 103. Select construction. Select s.name from sellers as resource s, where s.zip is equal r.zip and r.bid is equal 103. The corresponding SQL query. This query requires information from both tables S and R. To answer this query, a join operation needs to be performed. S.zip is equal R.zip. This specifies how S and R are to be joined together. Query 3. Find the names of sellers who have research bullet number 103. We start to calculate. S.zip is equal 22. R.zip is equal 22. S.zip is equal R.zip. R.bid is equal 101. R.bid is not equal 103. Condition is false. Do not output this entry. Next step. S.zip is equal 22. R.zip is equal 58. S.zip is not equal R.zip. Condition is false. Do not output this entry. We continue. We have the same operations of compare conditions. Oh, bingo! We have in the same time we have two conditions. Is true. Conditions are true. End of algorithm. The result of this query is Rusty as name. Summary of query 3. Result of SQL query requires information from two tables, a join operation is necessary. A simple analysis shows the state select row operations, where n is size the number of records of table S, and m is size the number of records of table R. Joins are expensive operations. This query can be decomposed into yeJoin, then yeSelect, yeProduct primitives. There are questions. You can think and write your own answer to the question, and after that compare your answer with right answer. Please write your answer on the last questions and send me by email. Thank you for your attention.